Now we will solve problem 3. We can see that problem 3 is a very complex circuit, so it is difficult to solve using Ohm's law. So we have to apply Kirchhoff's law. First we apply KCL at the different point. We mention the point A, B, C, D, E, F. So KCL at A. Here is I1. I1 is split into I2 and I3. So I1 equals to I2 plus I3. At B, I2 is incoming, I4 and I5 is outgoing. So I2 equals to I4 plus I5. So I5 equals to I2 minus I4. At C, I4 incoming, I3 incoming and I6 outgoing. So I6 equals to I4 plus I3. Now applying KVL at the loop A, B, C, F. KVL at A, B, C, A. Start our journey from A and we take the clockwise rotation. A to B, I to R2, then B to C. When we move B to C, we have to face the positive terminal of E3. So plus E3 plus I4 R3 plus I4 R4, and when we move C to A, minus I3 R3 equals to 0 because I3 is coming A to C and we are moving C to A. So putting the value of resistance, you can write 10 I2 plus 6 plus 2 I4 plus 6 I4 minus 15 I3 equals to 0. So we can write 10 I2 minus 15 I3 plus 8 I4 equals to minus 6, equation 1. Now KVL at B, C, D, B. That means B, C, D, B. So if we move B, C, D, B, this is anti-clockwise. So first we face the positive terminal of E3, that means E3 plus I4 small r3 plus I4 R4, then plus I6 R6, and when D to B minus I5 R5 equals to 0. So E3 6 volt plus 2 I4 plus 6 I4 plus I6 can be replaced by I4 plus I3, that means into R6 10, and I5 can be replaced by I2 minus I4 into 2 equals to 0 plus 2 I4 plus 6 I4 plus 10 I4 plus 10 I3 minus 2 I2 plus 2 I4 equals to 0. That is minus 2 I2 minus 2 I2 then plus 10 I3 10 I3 2 I2 6 I2 18 I2 20 I2, that means plus 20 I4 equals to minus 6. That is equation 2. Now now KVL at A, C, D, E, F, A. That means A, C, D, E, F, A. And we are moving actually clockwise. So we start our journey from A. That means I3 R3 plus I6 R6 and then positive E2, and here is plus I1 R2 minus E1 plus I1 R1 plus I1 capital R1 equals to 0. So putting the value of resistance 15 I3 plus I6 can be replaced by I3 plus I4 and R6 10 plus E2 4 volt plus I1 1 into I1, that means I1 minus 18 plus 1 I1 plus 4 I1 equals to 0. That is 15 I3 plus 10 I3 plus 10 I4 plus 4 plus I1 minus 18 plus I1 plus 4 I1 equals to 0. So after calculation, after simplification, we can write I1 6 I1, that means 6 I1 15 I3 10 I3 25 I3, that means plus 25 I3 and 10 I4 plus 10 I4 equals to 14. I1 can be replaced by I2 plus I3, so 25 I3 plus 10 I4 equals to 14. So finally we can write 6 I2 6 I3 plus 25, that means 31 I3 plus 10 I4 equals to 14. This is equation 3. Now solving equation 1, 2 and 3, we get, okay, now solving equation 1, 2, 3, we get I2 equals to 0.5543 ampere, I3 equals to 0.5045 ampere, I4 equals to minus 0.496 ampere, I1 equals to, putting the value of I2 and I3 at point A, I1 equals to 1.0588 ampere, I5 equals to 1.05 ampere, and I6 equals to 0.0085 ampere. So that is the answer for I1, I2, I3, I4, I5 and I6. Okay, thank you. Now we will go the next problem. Okay, now this is problem 4. This is another complex circuit, so start to solve this problem. First we have to denote the several points at the junction point, such as this is point A, and then B, C, D, E, F, G, H. So junction law at point A, K, C, L at A. At point A, I is outgoing and I1 incoming, I2 incoming. So we can write I equals to I1 plus I2. So this is equation 1. Then KVL at loop A, B, C, D, E, F, A. That means A, B, C, D, E, F, A. In this path, this is clockwise. So if we start our journey from A, first we have to face the resistance R1 and current, corresponding current is I, and the same direction. So we can write I R1, then the negative terminal of E4, so minus E4, and I R4, then I R2, then the positive terminal of E1 and I1 R1, then negative terminal of E2 plus I1 R2 equals to 0. So we can write I1 can be replaced by I can be replaced by I1 plus I2. R1 is 10, E4 10, 3 I1 plus I2, I1 plus I2, R2 5 plus E1 2 plus 2I1 minus 6 plus 1I1 equals to 0. So 10I1 plus 10I2 minus 10 plus 3I1, 3I2 plus 5I1 plus 5I2 plus 2 minus 2I1 minus 6 plus I1 equals to 0. That is 10I1 plus 3I1 13, 18 19 minus 2, that means 17 I1. Sorry, this is plus 2 I1, that means 21 I1. 21 I1. Again I calculate 10 I1, 13 I1, 18 I1 plus 20 I1 plus 1 I1, that means 21 I1. Now 10 I2, 13 I2, 18 I2, that means plus 18 I2 and minus 10 minus 6. So if we alternate the side, that will be plus 16. That is equation 2. Now KVL, Kirchhoff voltage law, at A, G, H, D, E, F, A, that means A, G, H, D, E, F, A, this closed loop. So we can see, if we start our journey from A, G, and when passing through the cell E3, we first face positive terminal of E3, that means E3 minus I2 small r3, then plus E1 plus I1 small r1, and then minus E2 minus E2 and plus I1 R2 equals to 0. So putting the value of resistance and cell, 4 minus I2, then plus 2, then 2I1, then minus 6, then plus I1 equals to 0. So after simplification we can write 2I1, 3I1, that means 3I1 minus I2, that is minus I2, and minus 2 if 6 minus 6, that means 0. That is equation 3. Okay, now simplifying 2 and 3, we get I1 equals to 0.2133 ampere, I2 equals to 0.64 ampere, and putting the value of I1 and I2 at equation 1, we get I equals to I1 plus I2, that means 0.2133 plus 0.64 equals to 0.8533 ampere. So I1, I2, I3, we can find all the value of I1, I2, and this is the solve of this 4 problem. আশা করি এই 4টা প্রবলেম যারা ভালো করে বুঝতে পারবে তাদের কির্চফের সূত্র প্রয়োগ করার ক্ষেত্রে, কির্চফের সূত্র ব্যবহার করে জটিল বর্তনী সলভ করার ক্ষেত্রে আর কোনো প্রবলেম হবে না। ধন্যবাদ। যদি তোমাদের এই ক্লাসটি কাজে লাগে তাহলে আমি নিজেকে কিছুটা হলেও সার্থক মনে করব। সবাইকে আবারও শুভেচ্ছা। আসসালামু আলাইকুম।